Hope you are doing great. Welcome back to my Tech Stack Learning channel. In today's sessions, we will see what is LangChain LCEL, which is LangChain Expression Language, right? And we will see in today's sessions what is LCEL and what are the different examples or how to use it, right? So stay tuned till end of the session. And if you haven't subscribed to my channel, please go ahead and subscribe. So what is LangChain Expression Language, that is LCEL, right? It is basically a declarative composable way to build the LLM pipelines, like using like a small blocks, or it could be like a runnables that you connect with the pipe symbols. Like pipe is this symbol, right? Which will give you like one API for sync async, and another for batch streaming tracing, or it could be for retries or fallbacks, or if it is for branching or any other thing, right? Simple composability like prompts, models, parsers, and transform fit together like a Lego, right? It's like a single thing. So we will see the live examples on how to use that. Okay, now let's start with some of the examples of how to use this LCEL, right? So let me put an example, demo.py. Okay, what I'll do is I'll take the basic code what we need, right? I think these are the basic imports. I'll just copy paste here. So apart from this, I need from LangChain core prompts. I need prompts import chat prompt template. Okay, this one I need. Then this is mainly for chat prompt template in the SEL expression. We can use it. Then we have LangChain core dot output parser. I will import. Okay, parsers I'll import str output parser. Okay, then I will be importing from LangChain core runnables. Then I will import a couple of runnables. Okay, so I need runnable utilities. Then one sec, I need RunnableLambda. Okay, RunnableParallel. We will see all these examples. Then RunnableBranch, and then RunnablePassthrough. Okay, these all I will be using it as part of this demo. Okay, then I also need some pydantic for structured output. Okay, so I will import pydantic import base model and then feed to structure it, right? And then we have this LLM, and then we will be loading it. The first example what we will see here is smallest LCL chain. Okay, so it will be just with the prompt, LLM, and parser. Okay, first what we will do is we will define the chat template. Okay, so chat prompt template from messages of, then here, then we will put system, then comma, then I'll say you are a concise expert. Okay, then I will put user comma explain topic in 3 bullet points. Okay, so I have my prompt template defined. Now what I'll do here is I will define a simple output parser that actually returns the plain string. So I'll just put equal to str output. Okay, then I will be composing the pipeline with LCL pipe. So what I'll do here, chain equal to prompt with pipe symbol, LLM with pipe symbol, and to str, right? So here what we are doing here is first prompt, then go to the LLM, then to the convert it to the output parser. This is how we are defining the pipeline. Then what I'll do, I'll invoke them. Okay, so chain dot invoke of topic, I will say LangChain Expression Language. Okay, so let's keep running this and see how the response is coming up. Okay, cd LangChain course Python LCEL demo. It says runnable. Oh, I think I did a mistake here. It should be branch. Okay, so let's run. So why again there is a connection error? What it says? Connection error. Maybe my network is not there. Just a second. Let me check. So I had some internet problems, so I had to restart my system. So again, let's give it a try now. Says cd LangChain, then Python LCL. Hope this should work now. So why actually this matters is LCEL forces a clean boundary, like inputs, the templates, the LLM, the past output, right? It actually gives that. That is why it matters. You can see it has given the 3 bullets in a structured format, right? This is the simplest example. Okay, now let's see of something called binding. Okay, bind, just a second, binding model params. Okay, so what we will do here is bind a dot bind. Basically we have dot bind which actually fixes the provider specific arguments like temperature into a new runnable, right? So what we will do here is precise LLM equal to LLM dot bind of temperature equal to 0.1. Then what happens here is the same Azure deployment will actually overrides the temperature, right? That is one thing which we are doing here. Then we will use the partial, which actually fills the prompt variables you don't want to pass every time, right? So prompt partial chat prompt template dot from messages of, sorry, just a second, from messages of, then I will put system colon, not colon, you reply in language. Okay, then I will say user comma, then I'll say translate right. This is what I'll have the basic prompt template, and then put a partial, and I'll say a variable language equal to I'll say French. Okay, this is basically we are partially like filling the prompt variables, correct? Then we will do a chain. We will create a translate chain. Translate chain equal to prompt partial. Okay, what we're trying to say is first you do this prompt partial, then use this precise LLM, and then str output. Okay, now let's print the I will just cut, I'll just copy paste this comment, and I'll put translate chain invoke text. We will put how are you today, how are you, okay. Let's run and see. I think some syntax error before input. Where is it? Which line? Okay, so from message system you reply, oh wait, then this is fine, and then user translate, and this is fine. Okay, this should fix. You can see it has been translated and it has given the data, right? That is about the binding. So next we'll see about batch async streaming. Okay, so now let's see how this batch async streaming on the same chain works, right? So I do have this things from LangChain chat models import. So let's define the prompt template. Okay, we will use chat prompt template. From template I'll use, then I'll use tell me something about topic, then I will say chain equal to prompt, then LLM. Okay, so here the batch process many inputs concurrently, right? So I will create some topics which I will be just have it handy. So I have this RAG agents and vector DB topics. Then what to chain, while print chain dot batch of topics. Okay, this is for the batch, returns list of strings. Okay, now we will see how we can do with the asyncio. So asyncio dot run of chain dot a invoke of output topic L caching. Okay, this is about the async way of invoking it. And then let's see about the chunk. Okay, for chunk in chain dot stream of topic colon Langsmith tracing I'll give. Okay, here the topic. Then I'll say print chunk, then end, then flush equal to true. Okay, so let's try to print this. Okay, so let's see. Invalid syntax. What? This one is okay, and I think 3 is fine. Okay. So this is how you will be working with the LCL on batch async and streaming. So async is not defined, so I'll have to import it, right? Import asyncio. Yeah. So this is how how you can use this LCL for handling this batch async and streaming. Okay. Next, we will see with pre and post processing with LCL. Okay, we will see pre and post processing. Okay, so here what I'll do, I'll copy the same prompt which I'll be using. Okay, then I will say pre-process, like normalize the user input for me. Okay, so I'll create one function called normalize of inputs colon dict. Okay, then we have text equal to inputs of topics topic. Okay, then I'll strip it. That is how I am going to normalize it. Okay, then I'll say return topic colon text of 200. Okay, this is basically truncating very long input, right? Then what I'll do, normalize what is it? Equal to runnable lambda. We will call normalize function. Okay. Okay, so this is about the pre-process, right? Then we will see the post-process, basically enforcing a final period and title case for the first time, right? So I'll create final, so normalize, no, I have just put this final touch, that's the final output, right? So I'll say output str, okay, then out equal to output dot strip. Okay, if not out dot ends with of this, we will have out plus equal to, I will put one end, right? Then I'll say first, then rest equal to out dot split lines. Okay. Then what I'll say, first equal to first of colon 1 dot upper plus first of 1 colon, right? Return slash n dot join of first plus rest, right? Then I'll say finalize equal to runnable lambda of final touch, right? So basically we will have to now compose with normalize, then prompt, then LLM, the string and the post, right? So pre-post chain equal to normalize, then we will put prompt, then we will put LLM, then we'll put str output, then I'll put finalize. Then I'll say print pre-post chain dot invoke of topic. I'll give caching strategies. Okay, let's run. Oh, I think the old this one haven't. This is the output of the latest code, right? Okay. Now let's see the parallelism. Okay. So parallel, or we can call it as a concurrent, right? So here what we will do is we will use the runnable parallel fan out and fan in. So here we will define three small subchains, one for summary keywords and another one for sentiment, sharing the same LLM. Okay, I have a code. Let me just go ahead and copy paste that, and I can go ahead and explain what we're trying to do here. Okay, so if you see, we have the summary chain, which is basically summarized in 2 lines, uh, and LCL with, that's a parallel pipe with these two, right? And then keywords, and then sentiment prompt template. Then we have runnable parallel, run all three in parallel. Output is a dictionary with specified keys, right? And then LangChain. So analyze and invoke. This is how we will be using it, right? This is about the parallelism. So let's I think I'll comment I'll comment this, and I think I'll comment this and comment this. I think that's it. And I think this as streaming. Okay. Okay, let's run and see how this parallel works. So it has given the summary, it has given the keywords, it has given the sentiment, right? So that is about the parallels, running runnable parallels, right? So now let's see what are the best practices to be followed, right? So think in stages like from dictionary to the prompt to the message to the LLM and then getting it passed, right? So compose with the pipe symbol and drop in utilities, right? So basically it will helps to pre-boost, like pre or post, you can use the runnable lambda. For branch, you can use the RunnableBranch, and for actually usually preferred like with a structured output, right? So if you want, then this is what the overall the best practices which you can consider. So this is the end of the sessions where we have learned what is LCL basics, how to use it, what are the different examples we can have this pipe or the LCL organized, right? So if you like my channel, please go ahead and subscribe to my channel and stay tuned for the next session.